Continuing on the topic of our last lecture, we talked about the steps how to prepare your presentation of technical information and present it in the right audience. Today we will talk about how to manipulate the data. We discussed a little bit last time how to create some columns of data and represent that data in a graph. Introduced a little bit into what type of graphs we could use to represent the data, and we mentioned that data representation in terms of curve is a good way to do visual for your data and be able to read the trends and see what's going on just out of visual without looking into numbers. There's a topic that you heard about probably from the instructor saying, hey, I did a curve fitting for your marks and I think blah, blah, blah is failing and blah, blah, blah is passing and all that stuff. I never liked that word while I was a student back in time. So what is curve fitting? It is defined as a process of constructing a curve, or you could call it a mathematical function that has the best fit of a series of data points, possibly subject to some constraints. Curve fitting can be done through two main methods. There's many methods to do curve fitting, but two main methods are, the first one is the method of selected points, and the second one is the least square method, which is the most accurate method. So you can see here, there's dots. Forget about the red line for now. So you have X and Y axis. Whatever the X axis is representing and whatever the Y axis is representing, you have a group of points, X and Y, like point 1, comma 2, point 2, comma 4, and so on. You go to the curve, okay, point 3.5 on the X, and 0.8 on the Y, that will be here. And you do that for the next one, whatever those data points representing, you have them on the graph with scattered points. In Excel, they call it scattered graph, where you get these dots, but you gotta input the X points and the Y points. Last time we discussed in our example, you have, I believe, the temperature versus height, temperature versus pressure. So this is how you write at what temperature the height was this much, and so on. So you have X and Y points, you represent them. Now what we're trying to learn here is curve fitting. It means draw me a line that represents the trend of the data in this case. So forget about the line one more time. The dots are kind of decrementing as X increase. You can see they're starting with a high Y, as moving to the right, like the whole trend, we call it as a trend, like the whole group, what they're doing, they're trying to go down as you move with X. So this trend needs to be represented as a curve fitting. There should be a line. If it's a linear fitting, then it should be a line. If it's another kind of curve, then you have another kind of curve. What you do between these points, we're gonna learn more about the method of selected points. Basically, you try to choose the starting point and the ending point and draw a straight line. There are some constraints into that, but we're going to learn together how to do curve fitting in hand and using Excel. Now, if you want to go with steps for the selected points method, first, as we mentioned, you plot the data on the graph, X and Y. Then you imagine the path of the straight line that could go through as many data points as possible. So we saw there's a trend, the dots are going decreasing from the X equals 0 all the way to X equal 5. So you see the trend where it's going. Now you want to start to imagine in your mind. Assume this graph doesn't have a line. You want to imagine, where should I draw the line? Then there's some things to keep in mind while drawing the line. Firstly, it should be, if it's a linear fit, then it should be a straight line. That straight line should go through as many points as possible. So you can see the graph or the line is touching some points. You gotta touch as much points as possible. Then you need to have the data points on the right, the ones that you didn't touch, on the right and on the left kind of equal. Not necessarily equal, but you do your best to make it as centered as possible to the trend of the data points. That's for the right-hand side of the line and the left-hand side of the line. When you're ready, then you draw the line. You select the points that the line cross. There is two, I would say, guiding points for the line. The starting point and the ending point. What does that mean? So we follow what the procedure is telling us. when you draw the line, or you want to imagine and you want to start to draw it, have as much points on the right of the line equal to the point on the left of the line. It's kind of you cut the data in half and either cross on the side or to the center of the point. Cross as much points as possible along the line. The last point is you want to define the starting point, like you start to cross from this point, and the last point that you crossed is this point. Those are your guided points. What's the use of those points? Maybe you know from your class of mathematics, you have this as x1, y1, and this dot as x2, y2. You can find the equation of the line. So you got to define the farthest 2 points from each other. Sometimes your line passing a lot of points. Just choose the farthest 2 points to the right and to the left that your line crossed, and try to identify those. What are the values of those 2 points? As we can see in our slide, let's say point A, that's x1, y1, and point B is x2, y2. Now I have a little training here. We gotta do together a line or a curve fitting, linear curve fitting for this graph together, following the points that we had earlier. So if you want to draw the line, what would you do? Now I want you to imagine for me or tell me where should the line go. So, okay, let's go. Forgive me for that, trying to do my best. Okay, let's assume. So now we crossed as much points as possible. My color choice was a bad choice. It should have been green or something. But you got the first point that you crossed is this point. And the last or the farthest point away from this point, I would assume this point, right? You agree? Okay. And I would assume the dots to the left of the line, or the points to the left of the line, are equal to the points to the right of the line, roughly, It's curve fitting, so it's like approaching the solution in this case. Now we identified, I would say this is point A and this is point B based on the procedure that we had together. We go through it. Now for point A, we got to define what was the point A. Can you tell me? It was x1, y1. What is x1?
160.
Okay, that's 1, comma, 60. That's the x value is 1. The y value is 60, and point B, you can write right away on the graph, by the way, but because I have space to the right, I'm writing it here. So how about B? Where do you think it projects? I would say
4.5.
Yeah, 4.5, and
It's probably a little bit lower, 9.
4.5 and 90 should be good for me. Okay, 4.5 for the x point, and would assume here, just for the sake of the illustration, of 90. Now, we had that written. Now we need to create the equation. Let's say that's your line. Now you need to create the equation for the line. Here we can see the line is a linear line. From your math class, you know the linear line equation should be in the form of y equals a factor multiplied by x plus another factor b, or I would say another constant b. So m and b here are constants, and I would identify, as you remember from your math class, m is the slope of the line and b is the constant that they call it intercept, or the value of y when x was 0. We want to start to build our equation. Assuming we are moving forward here, then you want to start to build your equation from the points A and B. A is having the points x1, y1, and B having the points x2, y2. Then you can plug it back into the equation. You'll have two stimulus linear equations, solving for M and solving for B. Then your equation would be, let's say, y equals 2x plus 3. Then that's the equation of the straight line or the curve fitting that you created. Now let's take an example together. The velocity v of a car measured at a specific time t, or a time interval t. Data is recorded as we see in the table. Now determine the equation of the straight line fitting for the data points. I would love to do it by hand, but that's fine. You can go ahead and plug it in into your Excel sheet. So let's have time t and velocity v, what we said. We can have it in a column style if you want. So time, then what's the notation of time? T, then what's the unit in seconds? You can have seconds in brackets just to identify that it is representing units. Okay. Time in seconds. Velocity v in meters per second. So we write velocity. Why we write that? So it helps us in the graph to show the naming of the things right away. That's the unit is meters per second. Close the bracket. Try to extend you can extend your column, in case you don't know, by holding it on his edge. I believe you guys know it. Now time, we said he go in a multiplication of 5, so 0, 5, 10, all the way to 40. So I can go 0, 5, 10, 15, 20, 25, 30. There's a way, by the way, in Excel to do it in an automated way. Just create an equation for the next cell. Like you can say A2 plus 5 or A3 plus 5 and put it here and drag that. He's going to give you always an increment of 5. That's something on the side. We have 24, 33, 62, 77. So we have 24, 33, 62, 77. Now we got our points, right? Now we can highlight the whole thing, the time and velocity columns, or even if you create them as a row, then you go to insert, then recommended charts. It's easier. You can pick up your chart from here right away, but for you now, you are being introduced to the system. Recommended charts, let him suggest for you. If you don't find what you want, then you go choose it. We don't find what we want because we want scattered plot. It means he show me every point in a scattered dot. You see that XY scatter? It's called XY scatter. You can choose one of these. I would say the first one. Hit enter, or select it. And you can see the graph. Here it should be time versus velocity. So I can call it as time versus velocity. That's the title of the graph as we learned last time. And we can add element, add the axis title, primary horizontal, which is the x-axis, what is called? That represents the time, comma, second. Not necessarily comma, just important, have the convention, what did you use for time, t in this case. Between parentheses, we can have seconds. So that means the unit of time is seconds. Go back to add element, axis titles, primary vertical, then you can call it velocity, or you can copy it from the column if you want to. But I want to rewrite it. So that's abbreviate as V. Then what is the units? Meters per second. That's that. You can, of course, change the dots to be something else if you want to. But now you can see the scattered dots. They are telling you there is a trend into the velocity versus time. Right? Now, when you're working with this, so now we need to draw our line digitally on Excel. If that paper, if you're able to print that now, I would love to let you do it by hand. But yeah, we're having problem with the printer. In Windows, you will have an option. In Mac, as I'm doing now, I'm not having the option to add the trend easily. So I gotta do it like the hard way. Go to Quick Layout and find the option of the trend, which is here, but don't do that yet. Like you see, he's drawing a line for you. So that one will add you a trend line, or you can have this. He will give you the equation of the line as well. Let's try this layout 3 first. So he drew the trend for you, or the curve fitting. But if you hit Control Z, I want you to learn another way and choose the plus sign, I believe. Then you can select the trend line. Now, I know Excel can give us the equation, but in this case, we want to create the equation manually because I'm assuming you draw that manually. But again, we are in the digital age. I support strongly using digital whenever possible. Excel easily can give you the equation of this line in almost no time. But let's say we are doing the solution manually. So you plot the data points on the graph. Let's say you have an XY graph. You plot it as we did in our Excel sheet. Now you draw a fitting line that will cross as much points as possible with balanced points on the right and on the left, as we mentioned, roughly. Now you define your points, point A and point B. So looking at this graph, do you agree with him that point A and B are the right points to choose?
I think so.
Well, for me, the point, to be honest with you, the point 40, like the point after B, is a more better point. Why? Because it's just more farther. Why we're saying being farther ahead? Because when you create the equation, you create a more accurate numbers for the equation. So you are trying to, curve fitting is just getting closer to the reality. You know, it's just telling you how the trend is going of the data. But the farther you are from point A and B, the more accurate you are. But we are fine with B in the exam if you just skip 1 point, probably, unless your equation is really off that you came up with. Like the equation should be 5x plus 2, then you end up with 10x plus 5. I wouldn't be picky on that. So you had your points, point A and point B. Now you need to substitute, you need to create the equation, which is y equals mx plus b, right? That's how the form, it's still a linear line. You need to first define, is this a linear line? Yes, it is. It's a linear fitting. Now we had the points A being T1, V1, and B, T2, V2. So in this case, A is a number, right? So what's T1 and V1 for A? So A, here's A, it's 10 and 50, right? So A is 10, comma, 50. Forgive me here, I'm writing on my touchpad. Okay, and B would be is 35, he's giving it to you, 35 and 165. How we know that? We go down to the x-axis where it hits between 30 and 40, that will assume 35. And here, almost 165. So 35 and 165, comma, 165. All right, okay. Now what you're gonna do, you know the equation y equals mx plus b. Now I want to use it here, but now we don't have y. What's on y? It's velocity v. What's on x? It's time t. So instead of y equals mx plus b, we have v, which is the y, you know, but a different name because you're representing v, equals m instead of xt, that's what on the x-axis, plus b. We need to plug in those 2 points into the equation and try to solve it to find the value of m and b. We should have v equals like 3t plus 2, 2t plus 5, and so on. Now solving the equation, plugging in back would give you m to equal 4.2 and b to equal 18. That means our line equation is v equals 4.2t plus 18. Can you do that by hand? Now, empirical equations, what we call as power curves. Power curves are the curves for the things up to the power of something, like 2 to the power of 3, or x to the power of 4, y to the power of 5. That's what they call as power curves. Not every curve fitting is a straight line. That's the simplest form. By the way, we mentioned the other method, which is the square, the least square method, or the Newton method. That one, if you know, in MATLAB, we had that one time as example. I know you guys taking MATLAB, so we had it before as example. If you want to go back to that and look at it, you can do it in MATLAB. But I'm not gonna teach it here because it's a digitized way. The way Excel gave you the equation, that is the least square method. But if you guys want to give you a handout, how does it work in details, I can send you a handout for it and read more about it. Now, if the experimental data doesn't fit a straight line, which happens a lot, you know, sometimes the data showing a trend as a linear trend, going ascending or descending. Sometimes the data is just going fuzzy, you can't match it in a straight line. Then you need to determine, that's where the magic happens. You need to determine which curve family would fit your data trends. Like now, if I removed for you the blue line, then it will be like, oh, what kind of curve would fit that? Touching as much points as possible, same rules, and keeping the points to the right of the curve and left of the curves to the same. That way, sometimes it would be confusing which curve you would go with, but now we're focused on power curves, so you shouldn't be confused. Let's take an example again. We have a solid object that we drop it from a tall building. The values of time versus distance, so he was collecting as time goes by and distance goes by, he's recording that. Recorded in the table we see on the right. Draw the data points and find the best curve fit that represent the data trend. Now, in your case, let's go to Excel since we didn't have the log sheets. You know, the thing is in curve fitting, you need to know there is some fittings that you can do in a mathematical book where all squares are equal. Some curves, they need to have log paper or template. Some of them need to have semilog. Do you know the difference between log and semilog? Let me show it to you. So this one is a standard, this way is just the standard mathematical, what they call it, rolled paper or kind of graded paper. So all squares are the same size. So there is the log paper. It will look like this. You can see on the Excel it's going 0, 0.2, 0.4. It's even on the x-axis, but in the y, it goes 0.69, then 1.09, 1.5, 2, 2.5. It's not even, you know? Like you can imagine it as the squares are being squeezed, getting closer together. That would be a log paper. Then the semilog, it will be the same but almost different. Let me find it for you. I believe it's somewhere here. You can see the semilog here. It's just more squeezed, you know, like you have 10, 15, 20, 25, 30, and so on. It's even on the x-axis, but it's squeezed on the y-axis. You can see from 10 to 35, big distance, 35 to 100 squeezed, you know. Like the boxes forming the paper are not, they follow a certain behavior, but they are not totally equal. Why we're talking about that? Sometimes when you draw, you know, your ultimate goal is to have a linear line. It's easier to find the equation of the line and all of that. Well, when you go to curves like this, there is a way to make the curve straight. How to do that? If you draw those points on a log paper, then the points will be having kind of a linear path. So instead of drawing a curve, you can draw a line and create an equation for it. Take the log for that equation, then you can come back to this curve. It's an easier way to find the equation of the curve. But if we're going to give you a list, if you identify what curve it is, and you know the equation representing him in a general form, then it's better to go with the curve right away in a standard paper. Okay, let's go back to our example. So we have time, t, in seconds, 0 to 6. Then distance, 0, 4.9. That's in units of seconds. Then we have what? We have distance. Well, I love to have distance abbreviated as d, but in this case, your textbook is having it as s. You can have it as s as well. That would be in meters. Close brackets. Extend the width of the column. Now we have 0. Then you have 1, 2, 3, 4, 5, 6. So highlight the data set in here. Go to Insert. Scattered plot is here. Let's increase it for you. Then this is not distance, this is time on the x-axis versus distance on the y-axis. That's that. Then we create a curve fitting for that. You can see anything, any notices about the curve? You see what happened? He didn't keep the same graph that he used, the standard one. He let you jump into, I believe it's a log kind of graph, so that he can draw it as a straight line. While if you do it manual, it's like a curve. There's a curve into it. It's not linear. So he took it into a log graph to show it to you in this form. While if you hit Control Z, it should be curved, right? Like if I want to draw here, it should be a curve going through these points all the way to the top. Like all the way to the top, right? But Excel, that's the limitation of using digitized form, because I'm sure there's a way to do it here, but he didn't support it because he can't generate the equation for you here. So that's how to create a curve. It's still, what he did for you is true, but doing it by hand, you're gonna see a curve looking similar to the curve you see right now. So plotting the data points, and we found the right, we need to find right now the right curve type that fit the data trend. I know if you are very good in math, you should be able to identify what kind of curve is this. Because, we talk about power curves, so it's a power curve. It starts as an S, start curving up, then it will go concave on top and go curving down. So if you continue with these data trends, you're gonna see it more clear as a power curve. The more you can visually identify the curve, the easier your life in doing curve fitting. And by the way, now we are in the age of big data. Many people are looking at data and they see trends. The more you're good at catching the trend, the more genius you are, the more valuable you are. Like if you're a data scientist with Ford, they are having connected vehicles. They're always collecting data from those vehicles. There's a trend into how many vehicles break down, how transmission is doing, how engine is doing. So looking at the data visually and being able to predict the trend, that's valuable, like that's very valuable. The more good you are at that, the more you're valuable in that field. And that, of course, start with math. So here I listed for you, just for the sake of helping you, common graphs. You can see you have the horizontal line, zero slope. So in this case, y equals c, that's how the curve will look like. Or let's say how the mathematical line look like. Vertical line, when you have x equals c, x equals a certain value, or point c and 0, then you're going to be just a vertical line passing the point of x in this case, which is c. You have linear equation will look like this. Linear equation negative slope look like that. Y equal x squared. You can see how the curve look like. Y equals x cubed. Your solution for saying quadratic was half correct, or it's correct in a different way. It's a power curve, so something to the power of something, but it's not necessary to the power of 2. You can see to the power of 3 is fitting more than to the power of 2. So that's another challenge to keep in mind. Then you have y equal absolute value of x. Then you have for the square root. So the more you're familiar with those, the better you are in creating curve fittings. Now, what we did here, so we know that a power curve or a power function in the form of course, as we know how to identify the curve, we assume we know the general form of a power equation. Now, the data trend should be in the form y equals b multiplied by x to the power of m. So we know the linear is equal y equals m multiplied by x plus b. Here in the power curves, forget about the straight line, that's because it's a log-log paper. We're talking about the previous curve. So in this case, it's a power curve. Y equals b, factor b, multiplied by x to the power of m. In terms of our solution or example, y in this case is s equals b multiplied by t instead of x to the power of m. Now you need to find the values of b and m to be able to find the equation. So either you go with the logarithmic way, or you go with our first approach that we did together here by solving two equations and find b and m. Either way is good, but logarithmic way, if you want to go through it, you have your time that's given, distance is given. Now what's the log of t? Each value of t, give it the log. Then you get the values of the log of t for each value. Then you take the log of s or the distance, you put them here. Draw the log of t versus the log of s on a log-log paper. That's going to draw for you points that are in a linear trend. So in this way, you draw a linear line. It will become a linear curve fitting. You can find the equation of the line. Then you can find the trend or the curve in this case by finding the equation of the linear line. Of course, to go back from the log, you take it to the power. Like e to the power of log will give you y. Like e to the power of log y will give you y. That's how you bring back your initial equation to solve it. But the other way, as I told you in substitution method, have equation 1 with point A1 and point B. Then try to solve for factors. So if you did the solution for this equation, you should have S equals M, in this case 4.9, and T to the power of B B in this case would be 2. Now moving forward, last 5 minutes, exponential curves. How does the exponential curve look like? As you can see in the right hand side, f of x equals e to the power of x, or f of x equal e to the power of minus x. Now again, if the data doesn't fit the straight line on rectangular coordinates or the regular paper that you have, or even you tried log paper and is still not giving you a straight line, then you need to plot the data on a semi-log paper, and it should do the mathematical solution for you so that you can find the line equation. As we mentioned here, like using E, you can find line equation by substitution, or we can use it by having the log paper or semi-log paper to get straight line, get the equation for the straight line, and take the log for that. Now here we have vehicle fuel consumption recorded in the table. Determine the best fit equation for plotted data. We gotta stumble on it fast. So velocity in V is listed. Fuel consumption in cubic millimeters per second is listed. Now your solution you take, you know that if it's an exponential, then its f of x would be e to the power of x. But in this case, we're going with the log method. Like we had a semi-log paper and we plotted the dots or the points, we had straight line. So that's the right format to use if you're doing things manually. Now we know that in this case, ln y would equal m of x plus ln b. That's the equation form of the straight line in the semi-log kind of representation. Now you can say fuel consumption FC. Instead of y and x, you can have ln, the fuel consumption FC, equals m by v instead of x plus ln b. Now plug in 2 points. Ln 470 equals 65m plus ln b. And you can have as well the other point, ln 33 equals 15 multiplied by m ln b. Solve the two equations. You will have m to equal 0.0529 and b to equal 14.8. And in this case, fuel consumption would equal 15 multiplied by e to the power 0.05v.